Good evening, students. So, hope you are all good. So, am I audible to all?
Yes, ma'am.
Okay, so first of all, congratulations to all 6 finalists of ICE Challenge. So, I'm Gopika and I'm the data science mentor of LA Techno Groups. So, now today is the final round of your ICE Challenge, and we have two prominent judges with us. The one is Yuvraj Rodare. He's a he's working as a senior deep learning engineer. So actually, he's a good example for you guys to start your career in data science because he has done his masters in material engineering from IIT Madras, and now he is working as a senior deep learning engineer. So he is from a non-computer stream, but still he is working he's working in data science domain because he has done many internships, and he has learned by his own, and he has turned his career to data science. So he's a good inspiration for you all. So welcome, sir, to this challenge, final round of this challenge. And we also have the another judge, that is Minu Jendi. She has done her master's in computer applications and from the RIT, and now she's doing her master's in data and knowledge engineering from Magdeburg, Germany. And she has worked as a professor on data science or data analytics, and so she's having a good knowledge in all those things, and she has also qualified in UGC net. And I welcome you, ma'am, also to this challenge.
Thank you.
Sir, can you speak towards to the students?
You're asking me?
Yes, sir.
Yeah, sure. So yeah, as Gopika gave my introduction, so yeah, I am working as a deep learning engineer, and yeah, I was initially from a non-computer science background. So data science is kind of a new, I can say, a newer field. So right now, I mean, if you want to get into this field, the best way to do that is to do more and more projects and familiarize yourself with what works and what doesn't work. And the best way to do that is to participate in competitions because you get to learn a lot. So I would say to all of the finalists that you guys are, I mean, on the right track. So theory is good, but you should also apply your skills, and competitions are one of the best way to do that. Yeah, I'm done.
Okay, ma'am, do you have something to tell to our students?
First of all, congratulations to all 6 participants on qualifying to the final round. And as Yuvraj has said, the main thing you have to do to get into data science is practice, practice, and practice. And this is a nice start, I guess. So wish you guys all the best. Thank you.
Okay, students, now let's start the presentation. Actually, you will get 5 to 7 minutes to present your project, and both of them will review your projects, and according to their judgment, they will put the marks, and tomorrow we will finalize the winner. So we can start it from Vinayak Deshpande.
Yes.
Okay, you can turn on your camera as well as you can share your screen.
I hope I'm audible as well as visible.
Yes, Vinayak.
Thank you, ma'am. I'll just share it right now. So first of all, good evening, esteemed judges and my fellow participants. I'll start the presentation right now. So the problem statement given was to understand supermarket sales across different branches to provide insights to understand the customer better. And obviously, this won't end without predictions. So the predictions should have been made on gross income, that is according to the cost of goods sold and the rating of the customer given by the customer. Fine. We'll start with statistical information. Okay, so statistical information first is provided for all numerical features, that is unit price, quantity, tax, total, cost of goods sold, so on and so forth.
I've used the dot describe method here, so we can get the total number of cases that is given by count, mean of the value, standard deviation of values, the minimum value in that particular feature, 25th percentile value, 50th percentile value, 70th percentile value, and also the maximum of that feature. So this is about the numerical features. For the categorical features for this data set is containing those as well. We are having gender, product line, city, branch, and customer type. So we can clearly see the count for each and every one of them, female, male, all the types of product lines, fashion accessories, food and beverages, so on, the cities, branches, as well as the customer type, which can be member or normal. Fine. Okay. So we are having the different counts given for each and every item in every feature. Okay. So pre-processing I'll come later, but first I'll go to exploratory data analysis. 1 second. Yeah. So first of all, if we call the data set, we have the data set in front of us. The shape of the data set is given by 1000, 17. That is 1000 rows, 1000 entries, 17 columns. That is 17 features. So gross income is the one to be predicted. So that is our dependent feature. Others are independent features. Fine. There is no null values in the data set, so that reduces our time for pre-processing a lot. So if we find the data type of all features, most of them are actually numerical features. So we'll get float value, float or int, and others which are categorical can be given as object. That is how it is given here. Fine. 1 second. Okay, now histogram. So what a histogram does is it will actually give the frequency of each and every quantity of the numerical features. So once we get to look at all the numerical feature, the histogram of all numerical features, we'll see none of them is Gaussian distributed, none of them make a bell curve. So it makes job a little tougher for us to make the predictions. For gross margin percentage, obviously we can see all the entries are the same value, so we can delete that column afterwards. If that's not used in our predictions. Box plot. So box plot gives us the median value, the first quantile and third quantile value, as well as the maximum values. So for the numerical features, it's given as shown below. We actually have some outliers here as well, which we need to take care of. Fine. Now correlation matrix, one of the most important visualizations during EDA. So because we have to make our predictions on gross income, so we can actually see gross income is highly dependent on many quantities, almost all quantities. For example, quantity, total, cost of goods sold, tax, everything. So we use all those features to make our predictions for gross income. Gross margin percentage, on the other hand, does not have any effect on gross income. It is very close to zero, as well as rating, minus 0.036, almost zero. So we'll neglect that afterwards. Fine. Now I'll just go back to okay, I'll finish data visualization. So from the plot, it can be visible. First question was which is the most popular payment method used? That is e-wallet. So it wasn't properly visible from the graph, so I had to do a value count separately. So e-wallet and cash, there's only one item difference between the two. But e-wallet is the most popular method used. Does gross income affect the ratings? So it does not affect the ratings. How can I say that? With the help of a regression plot. So if we make a scatter plot first and then fit the regression line over it, we can see that against the plot against rating and gross income is a flat line. There is no regression, there is no relation at all. That can also be confirmed with the help of the correlation map given. We can see between rating and gross income, it is almost zero. Which branch is the most profitable? If we plot a bar graph, we'll see that branch C is the most profitable. Is there any relationship between gender and gross income? No, there's no relation. But obviously, at the 75th percentile value, if it's visible, the females are tending to spend a little more. Okay, and if any specific time trend is observed, so if we look at this graph in general, that is the plot of gross income against time, we'll see that it's going up and down, very sort of showing like a time series plot. But if we look more closely, we'll see that there's actually no given time trend which can be observed. Fine. Okay. So what is the spending pattern of females and males, and which category do they spend a lot? So if we plot them against here, we'll see that females tend to spend more in the fashion accessories range, and males actually spend more in the health and beauty. Where's the health and beauty? Yeah, here. So they tend to spend more in the health and beauty range. Fine. how many products are bought by customers. So it wasn't specified which type of customers. So first of all, we see that most of the customers are buying almost buying 10 items at once. Plus, if the customer type is member, they have the members have got total of 2,785 items, and the customer type normal has bought 725 items. So in total, 5,510 items were bought. Right. Which day of the week has maximum sales? So if we convert the dates to weekday and plot it, we'll find that on Saturday the sales are the highest, which makes sense because it's the weekend and people tend to go to the stores to buy supplies for the next week. Right. Which city should be chosen for expansion and what should it focus on? So from the plot given before itself, we can see the branch C, which is corresponding to the city Napito. It is the most profitable branch in terms of gross income. And if we have to take a look at this graph given, we'll see that food and beverages as well as fashion accessories have the most priority and most people are buying them in these cities. Right. Which hour of the day is the busiest? We'll find that 2 p.m. is the busiest hour. Now, before we go to accuracy, we'll have to first see how to pre-process the data to make it proper for predictions. Fine. So we'll start with this. First of all, dropping unwanted features. So features like date, time, invoice ID, as we already saw, there is no relation of time with gross income. So we'll drop it. Invoice ID, that's obviously of no use. We'll drop that as well. Gross margin percentage was the same for all cases. We'll drop it. Handling categorical features. So categorical features are text, okay, and text cannot be interpreted properly by regression models. So we'll first convert them, we'll label encode them. Label encode them meaning, so each and every column, each and every item will be given one integer number like 0, 1, 2. So if it is female and male, it will be 0 and 1. So after label encoding them and dropping all the features, it will look something like this. So you'll see branches 0, 2, 0, 0. City can also be like 2, 1, 2, 2. Customer type, everything is in a numerical format now. And we have dropped date, time, and invoice ID. Now we'll have to split the data for training and testing purposes. So the splitting I have used here is 80% for training, 20% for testing. After splitting, making it into 4 different data sets, that is trained, X test, Y train, Y test. And if we plot the shape, it is given as 800, 200, 800, 200. X will contain all the independent features and Y is containing the dependent feature, which is the gross income. Now let's use all these things and predict the gross income. First of all, linear regression model. Once we plot the linear regression model, we are getting training and testing accuracy both as 100%. So even I wasn't satisfied at first. So for a second, if I go to my predictions and I show you, yeah, here it is. So if I show you, so this is the predicted values, 8.745, 21.4335 after linear regression model is applied. It is correctly and accurately matching with Y test values, that is 8.745, 21.43. It's the same thing. So the accuracy was the best for linear regression. That is, it was a perfect accuracy. Fine. So okay, I'm so sorry. So linear regression gives us a training testing as 100%. Next, we'll use extreme gradient boosting technique. So what extreme gradient boosting does, the technique does is it tries to minimize the cost function as fast as possible. Even this is giving us a good training and testing accuracy, but a slight dip from linear regression. Stochastic gradient descent. What SGD does is it will follow a probabilistic model to reduce the cost function. But here, this model is not giving us a good accuracy at all. Very poor accuracy. In fact, it is showing inverse relation, minus. It is giving us in minus training and testing accuracy both. So it was not a good model to fit at all. Elastic net regression. So elastic net regression is used for plotting numerical features when the numerical feature to be predicted is not a proper integer. So obviously it's not a proper integer because it's gross income type. Training and testing accuracy, once again, if we see here, is 99.99%, very close to 100%. Bayesian ridge regression. Bayesian ridge regression doesn't use the independent features as point features. So it will use the probabilistic model. So it will use the probability density of the independent features to predict the dependent features. So even here we are getting it close to 100%. Kernel ridge regression. What is kernel ridge regression is doing? This is used when it is a type of ridge regression again. So when one variable is dependent on more than one variable. Okay, so here gross income is dependent on so many things as we have seen from the correlation heat map. So again, if we plot it, we are getting a good accuracy. Training and testing both. Support vector machine. Now, support vector machine does not actually take into consideration the cost function. What it tries to do is it will try to fit the best possible line, fit the best line that is which is containing the maximum number of points of gross income. So that's what it does. Here, there's a slight dip from other model, 99.65778, but still pretty high accuracy. Gradient boosting regression. Here, it is not extreme gradient boosting, just a light gradient boost, which is giving us a training and testing accuracy as shown below. But finally, we can obviously say that this model was correctly predicted using linear regression. The inferences are the same things which I had discussed earlier, so I just skipped through these slides. And the conclusion was that is as follows. Sales from all the branches were done, as well as time series analysis of gross income was done, as we saw, but we didn't find any time relation, any time trend. Data analysis was carried out with the help of different graphs and plots, as seen. Gross income was predicted using different regression models. Okay, why did I use regression? Is because it's not a classification example, classification project. This is like gross income is dependent on some other variable. That's why regression model. Why logistic regression wasn't used here is because logistic regression is a classification model, not a regression model. Fine. Okay, and among which linear regression gave us the perfect training and testing accuracy of 100%. So that was my project here. I'll finish my presentation here. Thank you.
Sir and ma'am, do you have any questions to Vinayak?
Yeah, so I have one question basically. Vinayak, your training and test split is based on random split, right?
No, I first did it on 70/30 because the things I have made so far, it's like start from 70/30, then check if the accuracy is getting better or not. So 70/30 was not giving a good accuracy, but 80/20 gave a perfect accuracy. So
No, I'm talking about how the split is done, not the number of examples in training and test set.
How the split is done using the library itself, sir, sklearn.train test split.
Yeah, so that splits the examples randomly. It doesn't.
Yeah, randomly. Yeah, it's random. But the thing is, the random will consist of 80% of the actual data. It's
Yeah,
not like that first 80%.
if you're doing a forecasting thing, the split should usually be based on time, because that's how in industry it will be used. Because
Yes, sir.
you are building a model now, you want to predict in future, not in past.
Definitely, sir.
Yeah, so that otherwise it was a very good presentation. Your ADA was on point. I mean, I can say you spent a lot of time in doing the ADA.
Thank you, sir.
So apart from that, just that small thing,
Yes, sir.
everything else was good. And yeah, so validation split is how we do the validation split is quite important. So
Yes,
that's
sir.
why I just wanted to mention that one thing.
Yes, sir. The thing was, sir, I didn't take into consideration that time thing because when I plotted it against time, there was no, what can I say? There was no proper trend which I was able to observe. That's why I thought maybe it's a random thing itself. And if I plotted it randomly, it was still giving a good prediction accuracy. Maybe that's the thing. That's the basis which I did. Hello.
Okay, ma'am, do you have any questions?
No questions. Very good presentation, Vinayak. All the best.
Thank you.
Okay, Vinayak. Okay, now let's start with the next. We can see the presentation of Rahul.
Hello,
Yes, Rahul.
yes, ma'am.
Yes, you can share your screen.
Yes, ma'am.
Rahul, are you there?
Yes, ma'am.
Okay, fine.
Now visible my screen is visible.
Yes, Rahul.
Okay, ma'am. Ma'am, I present my report for a project uh, for supermarket sales prediction. Uh, Here, first of all, the question which we have to solve is predict the supermarket sales on behalf of uh, the data set which we have provided, which is historical data set. And there we have predicted gross income of different branches of the supermarket across the country. Here, first we start from statistical information, importing libraries, important libraries for statistical pre-processing process, loading uh, data set, then visualize some step showing some insights from data. We have arranged data from uh, column, then describe it. Here we do some pandas functions on the report and gets insist from it. Here we check null values if the column has data set has null value or not. So our data has zero null value, which increase the speed of the model. Then we check some data in a visualization form to check insist from the data. Here is the plot count plot, which basically present the number of female and male from the data. And then we have cities, total number of cities, and how fraction of these cities have present here in bar plot. Then we have payment method, which payment method have customers adopt more and famous in so e-wallet is more customer choose to pay. And then we select branches, how many two branches. Here we do count basically visualizations. Then we change our data in categorical columns. In basically our data has object type, so we do some visualization. From this we convert it into numerical, which we can understand by the data frame. So we use lambda encoder to encode this our data encoded in, then performing some exploratory data analysis. We show some historical representation of our data. Then we check a correlationship between different features of data. It shows some visualizations. Between rating and different pair plots are present insist from our data, and then we plot a regression plot between rating and how gross income dependent customers behave. Rating gives the rating according to how gross income depend. Then this is here we only visualize, and this is all part for visualization part. Here we predict, visualize unit price and rating correlation between how ratings and unit price defined. And then basically we define our features. Here we predict gross income and assume rest of the our features. Then we split the trained data using library as from sklearn library. And first of all, we use learning algorithm K-neighbor classifier. From this, we get training score of 49%, which is not so much good. Then we use SVM, support vector machine, uh, which predict very low score, very low score 1.5. Then we use naive Bayes algorithm. It From this we gave almost 100 training score. Then we use decision tree classifier. From this also we get 100% scores. And also we do some other classifier using random forest and XG booster classifier. All of them we get 100% accuracy testing score, which predict the gross income basically from the remaining features on the behalf of the. Here we gave a result of a different algorithm provides. So from naive-based decision tree and random forest classifier, gradient boosting classifier, we get 100% testing score, and from k-neighbors and SVM support vector machine, we get low. So I think these four algorithm is more efficient and valuable for this prediction. Here we give some reference questions. Popular method used by the customer is wallet form. Previously, we have visualized according to all tasks we do. We give these answers. Uh, does gross income affect the rating that the customer provide? Yes, branch A has the most profitable branch, and the gender correlationship, we have positive correlationship between genders and the this is number provide trend in time with trend positive increase, and the spending pattern for females and males in different categories. Well, male spend more in health and beauty, and female spend more in fashion accessories. And this is whole customers product will they buy is the hair of. And that's all from my side. Thank you. This small presentation.
Okay, Rahul. So,
Oh,
sir, you have any questions?
None from me.
Okay, ma'am.
Rahul, why have you used a classifying algorithm here?
classifying algorithm because we have one feature which is gross income, and other we use as a label. So we train our uh, training our data on behalf of a 10 test speed. So that's why I have supervised learning for this one.
Okay. And about this time trend and about the spending pattern, have you shown any graphs or charts regarding the time trend and spending patterns in the EDA part?
Rahul, are you there?
Okay, it doesn't matter. No problem.
Okay, ma'am. So now let me call Lokesh. Lokesh, you can present it now.
Okay, am I audible?
Yes, you are audible.
Yeah, thank you. Hoping that the screen is visible and warm welcome to all. Uh, just wait a second. Yeah, hoping that the screen is visible to all. So let me first introduce myself. My name is Lokesh Santosh Parab. I live in Mumbai and I'm uh, recently passed out in 2022 in University of Mumbai. So without wasting any time, let's jump into it. So the problem statement is goes like this, that we had to analyze the supermarket sales and we had to predict the gross income according to the cost of good, that is a COGS, and the ratings by the customer. So we will see the visualization, the distribution, also the sales of the each branch and overview of the gross income. Okay, so let's we start with the statistical information. Uh, it is the main thing that we have to do statistical information, because first we need to understand the data set, like what is the mean, what is the mode, how the data is, how the data object is, there is any null value. So you can see I have made a data information and you can see the columns, the null count. So awesome, no learn means there is no null value, and you can see the unique values as well for each. The voice ID, of course, it will be unique. The branch, the city, the customer type, gender, product line, and many more. You can, and so this is the data set. I have plotted the head, means the topmost of the data set, and you can see the values as well. And now before we go into it, we just go in more in understanding the main, the standard derivation, minimum, the 25 percentage, and the 50%, 75%, and the maximum. And you can see that you can see the mean of the unit price, the quantity, the tax, total, COG, and gross margin percentage, gross income, and ratings. And also, I have mentioned the mode as well. For the branch, the city, you can see in the branch it is A, in city it is Yagon, and in customer type the member, gender, female, the product line of fashion accessories, and the payment is e-wallet. Okay, now we go on to the pre-processing. Uh, it is very obvious, like we have to do the pre-processing in order to analyze the data and also the prediction. So the first, after the statistical information, we go on to the pre-processing. And like I already said, there is no value, like checking the well value, there is no any null values. And if you can see, there is a new I had done with it, the date time formatting and adding the weekdays and hour columns. So basically there is one like infer question about the weekdays. So before, like I had to pre-process it, so I had converted in a date timeline of the panda. You can see that pd dot to underscore data time. So it will like just convert into a date time, so that I can extract the hours, the seconds. I don't need to just formatting with in a scratch. So that's why I just practice it on those things. So I have done it, and also I have also made the weekday column as well with using the function that is a weekday, and also I have added the hours. That is also it is taking the part in data visualization. Then after that, I have removed the columns like the gross margin percentage what is a constant. Like if you can see here, for the gross margin percentage, the the minimum 25 means you can like directly say it is the constant value. So I have just remove it. So I have remove the gross margin percentage, branch, date, and time. And this is the df dot final that we will get to know after. And after the pre-processing, you can see that how the data is there. You can see in date time that how the time, date and time are arranged. There is also weekend and also hours. Okay. uh, okay, now this is like afterwards the convert. You can see the date time. The d time is the date time 64 nanoseconds. So and the weekends and the hours. So I just for the data set information I have represented. Okay, now we go on to the exploratory data analysis. So, like you can see the correlation matrix here. Uh, if we look at about the ratings, you can see. Okay, first of all, I will tell you what is the correlation. The correlation matrix is there, which it tells about the each and every future how they are correlated. So basically, the relation is correlated is a term called correlation coefficient. As if it is like touches to one means it is a good relation. If it touch to zero, or then it is a not a very good relation. It can be also a negative as well. You can see in rating like 1 to -1. In -1, like the slope will be like above the 90 degree. So just that's it about the correlation. And you can see like in ratings like gross income, like any of the future is don't have any good amount of relation. But you can see in gross income, uh, if you can see in COGs, that is the cost of goods sold, it is a very good relationship. It is one also in total and also in tax 5%. And you can see for the other as well, like 0.6 in unit price and tax, unit price and total, unit price and COGs. Okay. Now this is the interesting part. Now from that Kurizuma, I have plotted like a relation, like how the data is looking. So you can see over it. Uh, See the pattern of a unit price section. You can see like it is like very awesome linear regression, and I will tell you what is that the meaning. And also you can see for the quantity as well. And for the tax, like it was correlation coefficient was one, so that's why they are linear here. And for the total, and this is all the things. And this is the histogram. The histogram is like for the every quantity it counts like how many counts are present for the each and unique value. So you can see the unit price, the quantity, they are just distributed. And I can here comment for the tax 5% like exponentially distributed, say for the total, for the COG, for the gross income as well. And for the ratings and data time and hours, it is just a normal. Okay, so I was telling about the unit prices, that how it was. So you can see over it the unit prices and the tax person. And you, if you group by a quantity, like if you can see uh the dark portion means it is a 10, means this is for the quantity 10. Then after this is line of the 9, then it is of the 7, then it is of the 6. So you can also directly comment it out like the slope, like the for the relation in unit price and taxes, the slope matters is the quantity. And also you can also see it is in unit price gross income as well. And also in unit price and total, uh, you can see the same thing. And a second part, actually, I just do it, but actually there is no need of it. But still, you can see over it the ratings that the quantity, like in the bottom, it is one and it is grows on increasingly, like above. But this is no need of use. Actually, I have shown it just because it goes very great. Okay, actually, mm, let me show you my notebook. It is very well present over here. Uh, yeah. Okay, so what I did, this is the interference. Like I have made the question as well as the data representative. Also, I have answered it as well. So, so let's start with the popular payment method used by the customer. And you can see I have made the pie graph, like how this is, and I would comment it like way that it is the customer are referring the three of the, like it is the, they are also referring cash, credit, e-wallet, means it is somewhat similar. Means we cannot like comment that the e-wallet is though it is more percentage, but yeah, but if we can like analyze it very clearly, it is but and if we term in terms of percentage, then e-wallet will be the better. It's popular payment. Okay. So does the gross income affect the rating that the customer provides? Definitely no. You can say over it. The gross income and the rating. Uh, you can see if we have made the relation plot graph, the data also it is scatter, and we can like just looking at the graph we cannot predict anything. So there is a no relation. Okay. If we talk about the which branches is most profitable, uh, here also same thing. Actually, if you can look carefully, the C is the most profitable, but uh, we cannot comment because the like the varying distance is not like high and low. It is like somewhat closest to it, and you can see this branch A and B. So means every branches are getting a good profitable, we can say. There is any relationship between the gender gross income? There is any relationship between the gender and the gross income? So I have made the box plot as well. Also, I have mentioned in statistical about the 25, 75. So basically, that's only the thing. If you can see, this is the 75 percentage. This will be the actual mean, and this will be and like it is also somewhat similar, and only at 75 percentage females buy more product than males. Is there any time trend in gross market? Sorry, gross income. You can see the graph is like zigzag, zigzag, zigzag. Whatever it looks like a stock marketing. So if you can see over here, like we cannot see anything like a specific relation. We cannot. So it is no. There is no any time trend in gross income. What is the spending pattern of females and men, and in which category do we spend a lot? Okay, so this, so I have made a graph like group by products, and we are counting it as well. So you can like specifically see for the each and every product. You can see for the health and beauty, the female buys low and males are buying more. For the electronic accessories, uh, the female is slightly buying low, the males are slightly buying more than female. The home lifestyle, the sports, and the food average means this graph is like many more information. But if we go with stick with the question, the female buys more fashion accessories, and the male buys a health booty, the orange one. Okay. So how many products are bought by the customer? Uh, Okay, so you can see this is the pie diagram I have made, and the actually we have a total of six, and also we have mentioned that how many percentage the product are buying, and you can see I had just exploded the highest one, that is the fashion accessories, and I don't know, like it is telling about the products, so I would comment that we have a six products. So customers are buying six products. Okay. Which day of the week has the maximum sales? Yeah, so I have already done in pre-processing that I have made the separate weekday for the column, and from that I can easily find out the count as well. And you can see like it is in descending descending order. The Saturday has a more maximum sale, then Tuesday, then Wednesday.
Lokesh, you can make it a bit more faster, like we don't have much time.
Okay, okay. Okay, okay. Sorry, I will go very fast. Which city should be chosen for expansion and which product should is focused? So you can see. Let me go in a down. Like for each and every city, this product the highest, which is the home and lifestyle. This city, for the food and beverage and Mandalay. Sorry if I'm pronouncing wrong. It would be the sports and travel and fashion accessories. Which hour of the day is the busiest? And this is the this is the bar graph I have made, and you can see the 7 p.m. is the most busiest day. Okay, so without wasting any time, I just jump faster for the model prediction. Okay, so see, so I have first used the linear regression. So the first feature, like if we talk about the specific as per the problem step, we have to predict uh, we have to predict the gross income with COG, means the cost of goods sold, and the ratings. So I have used these two input feature as a input, and I have trained it. So blah blah, 100% score, and there is a no absolute error, square error, root mean error, and you can see the regression intercept, the slope, like slope for M1 means it is for the COSG, and the another that is a rating, and I have made this line equation like how the things will work, and I plus I am very straightforward. If you are getting the model score and with a symbol regression, I think you shouldn't go for the gradient boosting, because the complexity also increases, and if you are getting a very simple straight and answer, so I have just done with this multi regression as well. So okay, so this is the, I think I have all answer here as well. So I would conclude that the model prediction is giving 100% plus we have visualized the data, and that's it. Thank you. So do you have any questions?
What was your split, Lokesh? How did you split the data?
Yeah, okay. I will show you. I will show you. I have. Okay. Actually, I had done like model one and model two, but the city is
Okay.
like
Yeah.
inputs, right? But okay, let me show you that.
Yeah, I can see that it's random.
Yeah,
So
it is a random state, and the test size is about 0.2, means a 20% it is the test case and the trend.
okay. Yeah.
Yeah.
So very clean presentation. You spend a lot of time on ED as well. Your graphs were also very on point. So
Yes.
good,
Yes,
good
sir.
presentation overall.
Yes, sir. Very sorry for the time. Actually, whenever I present, I take very lot of. Thank you so much.
Okay, next, Pavan goes next. Pavan?
Can you hear my voice now?
Yes, Pavan.
Okay. So is my screen is visible, man?
Yes, it's visible.
Hello.
Yes, yes.
So welcome to one and all who are present here. My name is Pawan Kumar. So thank you for giving me this opportunity to present my project. Moving on to the project. So the problem statement was to analyze the sales across different branches and to predict the cost of goods sold and rating, comparing with the gross income. Can you give me a minute? So first, we need to understand the data, like attribute information. Attribute as follows is like invoice ID, branches, cities, customer type, member, and so on. So firstly, we are going to import libraries like NumPy and Pandas, Matplotlib, etc., and finding out the number of rows and columns. So here the number of rows is 1000 and the number of column is 17. So coming to statistical information, as you can see the 5-point summary, which is also known as Q1, Q2, Q3 minimum and maximum. So data after understanding the data, then further moving for data pre-processing. So checking is there any missing values. So I found out that there is no missing values in this data. So and converting date column into a date type. So and also adding a date and also adding month and weekday column in data. So city column is deleted because both city and branch are similar uh, level of significance. So it has been deleted, and it also reduces the dimension of data. So I used a label encoder to encode my data where my previous data was like object type data. So I converted into integer. So coming to exploratory data analysis, so I used it to find total sales of each and individual branch and total margin income. So the total company's income was margin income was around 1.5 billion, and the total sale was $332, three 322K. So these are the different branches total sale and margin income. So this shows the highest and lowest sales record per day. So minimum is 12 and maximum is $1,039. So coming to data visualization part, so highest sales for each branch of any data as follows. So as you can see, branch C and branch both has an highest sales trend. So considering individual highest sale of individual branch highest sale. So as you can see in branch A, February has highest sale and lowest sale is January. And in branch B, the highest sale is in March and the lowest sale is in February. So at branch C, the highest sale is on February and the lowest sale is on March. As you can see, the sales of each product, the bar plot shows the food and beverages are more sold. So coming to the accuracy and of each model, before implementing any model, we need to test and train the model. So I used to like splitted data into 80-20% split. Like 80% of like if you have 1000 rows, then I splitted 800 rows as 80% and 20 rows as test data. 80% as trained data, 20% as test data. So I have implemented a linear regression, lasso regression, and XG boost regression. So my first model was linear regression, which was imported from sklearn. So as you can see, I assigned an x and y value as dependent variable, that is gross income, and x value as and rating and uh, cost of goods sold. So which gave me like r square value as 1, so which is also known as 0% variance, like 100% of accuracy. So the second model is lasso regress. So in this I got an r square as 0.99 with 1% error in variance. So my third model was like XG booster regression. So I got an accuracy of 100%. So conclusion is like we got a good accuracy about 100% in both linear regression and XG booster regression. So this shows that both rating and gross income are dependent on both rating and cost of goods sold are dependent on gross income. So inference, the most popular payment method used by customer is both e-wallet and cash, because both are comparatively similar. And as you can see, the gross affect the ratings affect customers. So it shows like as you can see the box plot maximum and minimal value. It seems to it has a similar type of rating, so it doesn't affect the gross income. So which branch is most profitable? I can say the branch C is the most profitable, as you can see in the plot. So is there any relationship between the gender and gross income? As you can see, male and female customer have comparable gross income, though female customers spend slightly more than that of male. As you can see in box plot in 75% of Q3 value. So is there any time trend in gross income? As you can see, the plot is like upside and down. So we can consider it as an average. So what is the spending time of females and males in so it's wait. So what is the spending pattern of females and males in which the category do they spend a lot? So females spend the most most on fashion accessories. So as you can see the plot, mm, wait. Just a minute. So as you can see, the female are most spended in fashion and accessories. So male spend the most in health and beauty, although male also spends in sports and travel. So next question is like how many products are bought by customer? So the majority of customers purchase like 10 quantities. So which day of the week has maximum sale? As you can see the plot, Saturday has the maximum highest sales. So surprisingly, Tuesday also have the highest sale compared less than the Saturday, but Monday has the lowest sale. So which city should be chosen for expansion, and which product should we it focus on? So basically, I say brand C has and more profit, so I would recommend to expand it in brand C. And which hour of the day is busiest? So as you can see in the plot, the 14th hour, that is known as 12 p.m. The afternoon was the afternoon sale was much higher. So thank you.
So,
Why did you choose Lasso regression?
So I have chosen randomly, sir. Like all regression, lasso regression models.
Um,
Even lasso regression has a like shrinkage, so it absorbs the mean, like it acts like central. It absorbs the all data points in central point. So I used that lasso regression.
okay. Yeah. Otherwise, yeah, your answer is correct, and otherwise, it was a good presentation.
ma'am,
Thank
do
you,
you
sir.
have any questions?
No, ma'am.
No questions.
Okay. Okay, thanks, Pawan. Next, we can go on with Vinayak Soni.
Yes. Hello, everyone. Good evening. My name is Vinayak Soni, and I've completed my graduation from Pune University in the field of mechanical engineering. So, going on to the project part, I'll keep this presentation short and up to the problem statement itself. So the problem was to understand the sales across different branches and the city doing much higher sales. So this is my statistical information. There were around 1,000 rows of data, and as we can see, we can get the statistics from here itself. As we can see from the data, our data. This is the statistical information for all the numerical feature itself. So the from this data we can see that the data is normalized basically, except these two features, that is COGS and gross income. And this is the statistical information for the categorical columns. As we can see, the date has most of the rows filled with hash values. So so getting information or insight from this column will be like unuseful, and it will give the inaccurate data as well. So in the pre-processing part, I've done like from the time I've converted that to date time, and extracted the hour from that column, and I've dropped all the NaN values. I've used a standard scaler for scaling, as some of the models like linear regression is based on the residuals are calculated based on the distance itself. And this is my exploratory data analysis. From the inside we can find that the number of branches are almost equal, and each branch corresponds to a particular city itself. There is a noticeable difference in sales as branch C, which also belongs to Napa city, as we can see here. Yeah, the sales from branch C is high, comparing to both other branches, as well as the branch C belongs to the Napito city, which does this sales much higher than both the branches. The gross income generated by female is slightly more than males, as well as the gross income generated by C branch is comparatively more than the other two branches. The rating given by the male and female across different city is also same. There is not much difference, and the payment mode of credit cards is slightly less used than other two modes. And as we can see, yeah, here in the left most corner, as the cash payment is widely used, and the highest buying product by female is fashion, at least bought and least bought is from health products, whereas there is no significant difference buying in buying of males. In Yangon city, here, the highest sales selling product is of home, and in Napito city, the highest selling products are from food and fashion, whereas from Mandalay, the highest selling products are fashion and sports. Sales is highest at like 2 p.m. and majority of the customers total lies between spending limits is between 10 to 200, so as for gross income and COGS. The majority of the product has a unit price of 25 or 95. Rating given by customer is almost similar, whereas the majority of the rating received are 4.5 and 9.6. So these are my data visualization. As we can see, the peak hour timing is around 2 to 3 p.m. And these are all the graphs. And coming to the correlation, a model building part, as mentioned in the problem statement, we need to predict the gross income according to the cost of goods sold and the rating given by the customer. So I have used those features only for prediction of the gross income. And from the correlation chart, we can see that the gross income is highly correlated to the COGS here. But there is no significant relation between the gross income and as well as the rating. So definitely our model will perform good on the basis of this feature. If I come to the so I have used a linear regression model first, and it was giving around like pretty much good score, or around like 100% itself, as the RMSE and MSE score was like 10 raised to minus 29 and all. I've used also cross validation for if like for checking that if it doesn't overfit and all. I've used 5 folds for it, and the mean I'm getting is around like minus 2, the 2.2 into 10 raised to minus 29. And if we compare the predicted and the actual value, we get almost the same value as we can see over here. I've also used decision tree model and random forest as well, but the linear regression perform wonderfully in this, as we it will anyways do perform well, because the output variable is highly correlated to our input variable, that is gross income is highly related to the COGS, that is cost of goods sold. And coming to the I've also answered all the inferences, that is popular payment method used by customer is cash, and like you can see, it doesn't have any effect on like gross income doesn't have any effect on the rating that the customer provide. Which branch is most profitable, that is branch C. Female spend slightly higher than the males. And is there any time trend? Yeah, there is a time trend according to me, and according to the graph as well. And what is the spending pattern of females? Like there is no spending patterns, but we can from the hypothesis we can say that females tend to spend more on fashion products. How many products are bought by the customer? Generally 9 to 10 products are bought by the customers. And which city should be chosen for expansion? That is Napito city, as the sales of this city is highest. And I'll come to that point. and which of the day is the busiest, that is 2 p.m. So the conclusion is what was the problem statement to get the sales analysis, where we so the conclusion is basically we can look out for the products which are not doing well. For example, in Napito City, we the highest selling sales generated are from this city itself, but there are some products which are lacking the sales, we can see the home products as well as the sports, and so we can look into the problem towards it. What is the problem, that why this city and why this branch is lacking those sales? If if we find the problem, we can definitely increase the sales drastically. As we can see in other cities, those products are performing well. The sports is performing well. The home products are performing. So if we compare out the layouts or the merchandising layout of the both these stores, we can definitely find a solution. So how can we increase the sales of these cities? And one more thing I need to include in this conclusion is, as we can see, the time trend, the peak hours is basically 2 to 3 p.m. and somewhere around 11 p.m. 11 a.m. So if we suppose when a customer goes to a store, he generally see at the peak hour, he generally says there is a huge rush in the queue, so he back off, he won't go to the store. So if we come up to some solution, at these peak hours, if we we utilize all the cash sales so that the billing process gets much faster, so customers will come more and the sales will be generated more. So that was my conclusion and the end of the project itself, presentation. Thank you.
Okay, Vinayak, sir, there is any questions to him?
No question, Vinayak. Very good presentation. You kind of answered the question why linear regression is performing the best here,
Thank you.
which was which tells that you had some insight into the data, and you were also specific about the error metric that you were using. You specifically mentioned MSC, RMSC, and stuff like that. So yeah, details matter. So very good presentation.
Thank you, sir.
Okay, now let's now move on to the last one. That is Abhijit.
Am I audible, ma'am?
Yes, Abhijit.
Okay. Good evening, everyone. First of all, I would like to thank the ETG team for giving us this chance. So let's directly peek into my Jupyter notebook. Here in this IC challenge, we have given a problem statement to analyze the supermarket sales across the different branches and provide insight to understand the customer better. Before starting, there is a question that what means analysis. Analysis is the process of breaking the complex topic of substance into the smaller parts in order to gain a better understanding of it. We have provided with the historical sales of the sales, which is very popular on the Kaggle, which has recorded in 3 different branches for 3 months data. For the analysis, we have imported the NumPy, Pandas, Seaborn, Matplotlib. I have also used the Plotly, and so you will I think you will enjoy the visualization made from the Plotly. We have used some custom shades. I love the blue color, so I have used the blue shades. So after that, we have also imported the sklearn for the modeling. In statistical information, we have finded the shape, size, info, number of unique values in each column. And as a part of data processing, we have checked if there are any null values, if there are any duplicate values. We have renamed the column types, column names to the Python standard. We have also changed the data to appropriate type, also extracted our day, month, year, weekday from it. In in the ED analysis, we can see that the maximum rating we have, which is 10. The average quantity is 5.5. The average gross income is $15.37. We can from this outliers part, we can see that the uh, tax, the COX, the total, the gross income have outliers. I have also tried to remove the outlier, but it results in disturbance in data. So I have commented that part. So let's start with the visualization part. I have tried to visualize all the inference questions. So let's start with the first question. Popular payment used by the customers. Cash is mostly used. E-wallet is the runner-up, but the credit card seems to be less preferred method, lagging behind by almost 3%. Median the median cash transactions are higher for health and beauty, the fashion accessories. People prefer to not to use cash for sports and travel products. People use cash if they want to buy expensive stuff. People use credit if they want to buy many stuff. So let's move on to the next question. Does income affect the ratings that the customers provide? So rating is very weakly correlated to the remaining features, means that the amount of money spent does not necessarily influences the ratings. And from this we can say that there is not clear relationship between gross income and customer rating. This is we can confirm it by the fact that the trend line is pretty flat. Uh, which branch is the most profitable? Then the branch C is most profitable. Branch A and B shares the same amount of profit. Now next question. Is there any relationship between the gender and gross income via unit price, quantity, and total? However, buy more items on each visits. Also, the profits is higher for the woman. Woman gave higher median rating. This implies that woman could be interested in some deals, some discounts, especially the ones that offer less price or for more goods. Women buy more cost effective options, hence the complementary product should be kept together in the store, and the company should try to introduce offers which targets the women. Ad should be designed keeping women shoppers trying to make the most out of their money. So is there any time trend in gross income? Uh, we can see that there are some time trends are found in the day. On 7 p.m., most of customers buy goods for the supermarkets in Yangaon city. I think maybe it's because people come home after school or work, or maybe it's because the dinner time. Around 11th hour, most of customers are buying goods for those supermarkets in Napito city. I think it's because they people mostly go to work or school, or maybe because it's time for a short break. In terms of city, the Mandalay is busiest between the 14th and 17th hour, between the 2 p.m. to 5 p.m. It's because of the lunch time. So what is the spending pattern of females and males in the in which category do they spend a lot? Spends a lot. So in this, we can see that women who are members spends a lot on health and beauty, electronic accessories, and foods and beverages. The non-members purchases electronic accessories, home and lifestyle, and health and beauty. So let's move to the men's part. The men's members generally buy the health and beauty part, the electronic accessories, sports and travels, and non-members men buys home and lifestyle, sports and travel, and electronic accessories. How many products are bought by the customers? the most customer buys 10 products, supermarkets can develop promotions for top buying customers who already have proven track record of purchasing product to encourage them to buy a higher quantity of products. Large number of uh, uh, customers ends with buying a single product, so supermarkets can offer them some sales initiatives. So the next question, which day of the week has maximum sales? Sales are highest during the Saturdays. Uh, in branch B, Tuesdays are closed one, Mondays are the lowest in sales, probably because it is starting of the week. On Sunday, the branch B has the lowest sales. Which city should be chosen for expansion and which product should it focus on? Mm, From the analysis, I will suggest to open the store in Nepto with a full backend inventory of goods, foods and beverages, fashion accessories, and electronics. Number of customers in Nepto are the least, but they tend to spend more on each purchases. High means higher unit prices, and also buys more numbers of goods in each purchase 6 as compared to the 5 in other two cities. Member spends more on each visit. The female shoppers are more inclined towards the membership, so supermarkets must initiate extensive membership programs, especially for the women. The company should improve service in electronics domain. Uh, the prime target for the marketing should be women. Which hour of the day is the busiest? If we consider all the branches, supermarkets are busy during the 2 p.m. And if we check the branch-wise distribution, then the branch A uh, is busiest at 7 p.m. in the evening. Branch A and B are generally busiest uh, in the afternoons between 1 to 5. 1 to 3 p.m. So let's jump to the modeling part now. As we need to predict the model based on cost of goods sold and the rating given by the customer, we are dropping some unused columns. We are installing some modules from the sklearn to separate the target and features. We can just attribute the data frame. We can just attribute the data frame columns values of x and y variables, just we do in the learning part. We have separated the testing and training part. We have taken the ratio as 80:20. So I have used the linear regression. I think it is the easiest one. It uses the relationship between the data points to draw a straight line through all of them. After all, after that, we have made the predictions on the test data. After converting it to the data frame and comparing, we can see that the actual and the predicted values are close, or what we can say, which means that their model is more precise. We got training score as 100%, which is very good. After the accuracy part, we have drawn the regression line. The slope value shows what happens to the dependent variable whenever there is an increase or decrease of 1 unit of the independent. At last, we have found the mean absolute error, the mean squared error, root mean squared error. In each case, we got 0, which it generally means that it is better. In a nutshell, I just want to conclude that, as discussed in the inference findings, it is more important to turn regular customers into members, as this can have a very positive impact on the sales numbers across the stores. Especially, it is important to attract the female customers since they outspend male customers by 7%. We have found some areas to improve, such as rating across all the stores Improved rating means happier customer, which can lead to increased retention and the possibility of the transformation of customer to be a member. So with this, thank you.
Sir, do you have any questions?
No questions. Good presentation, Abhijit.
Yeah, ma'am, do you have any questions, ma'am?
No questions, but very well analyzed. Good presentation.
Okay, so students, our judges have reviewed your projects, and tomorrow we will announce the final winner. So thank you all for being here in the live session, and a special thanks to the two judges, Sivaraj sir and Meena ma'am, for being a part of our live session. So thank you all. You can leave now.
Thank you, ma'am.
Thank you, ma'am. And thank you, judges. And thank you, all of you. Very
Thanks a
great
lot.
presentation.